You type 3 words into a search bar. Why am I? The autocomplete finishes it for you. Here, alive, breathing. For most of human history, that question was not a search query. It was the floor underneath everything else. Every ritual, every star chart, every story told around a fire was an attempt to answer it. Then we stopped asking. We replaced it with productivity. We replaced it with weekends. We replaced it with a phone screen at Tawait, scrolling for something we cannot name. The question went underground, but it never went away. It just stopped being something we trusted ourselves to answer. And what you are about to find out is that 3 different scientists, a physicist, a chemist, and a mathematical cosmologist, independently arrived at the same conclusion in the last 50 years. None of them set out to answer it. They were studying expansion rates, thermodynamics, and 14 billion years of carbon. The math kept pointing in the same direction, and the direction was strange. It was that the universe has been doing something specific from its very first second, something that has your name on it. By the end of this, the question you were taught to be embarrassed about is going to look like the only question that ever mattered. To understand how strange this is, you have to go back 500 million years. The ocean is cold and dark at depth. Salt, heavy water presses on shells that have never seen light. There is no sky. There is no concept of day or night, because nothing alive has ever distinguished between them. Then something happens. A small armored creature, a trilobite, develops the first lens, the first eye. A creature pierces the darkness and sees. That is the moment, in the geological record, when the universe became something that could look at itself. Before that, for nearly 4 billion years, Earth had been a chemistry experiment running in the dark. Hydrogen had cooled into stars. Stars had exploded. Carbon, oxygen, phosphorus, gold, every element in your fingertips had been forged inside dying suns and scattered across light years. Volcanoes had outgassed an atmosphere. Single cells had learned to copy themselves. None of it had been witnessed. Then a creature opened its eyes. And here is the part nobody talks about. The salt water of the ocean, where that first eye opened, has roughly the same concentration of sodium and chloride as the fluid surrounding your cells right now. You are walking around carrying a piece of that 500 million-year-old sea inside you. The creature that first saw is, in a quiet sense, still seeing through you. So if the universe was already in the business of growing eyes 500 million years ago, what was it doing for the 13.5 billion years before that? In 1988, the physicist Freeman Dyson, then in his 60s, working at the Institute for Advanced Study in Princeton, the same desks once used by Einstein and Gödel, published a book called Disturbing the Universe. It was part memoir, part reflection on decades of cosmological physics. Buried in its pages was a sentence that quietly broke the rules of his field. Dyson had been examining the early universe, the first second after the Big Bang. He looked at the constants, the strength of gravity, the mass of the electron, the expansion rate of space itself, and he found something that should not be possible. If the expansion rate of the universe had been 1/millionth of 1% slower at that first second, gravity would have collapsed everything back into a singularity within minutes. No galaxies, no stars, no carbon, no you. If it had been 1/millionth of 1% faster, matter would have been flung apart so thinly that no 2 particles could ever have found each other. No atoms, no chemistry, nobody here to notice. The window was vanishingly thin, so thin that, for the universe to produce a single living being, the dial had to be set to a precision of roughly 1 part in 100 billion billion. And it was set there from the first second. Now the standard objection arrives quickly, and it sounds reasonable. Of course, the constants look fine-tuned. If they were not, nobody would be around to notice. It is called the anthropic principle, but read it again. It explains why we observe these constants. It does not explain why the constants are what they are. It is a description of survivorship, not an answer. Dyson sat with that gap for years, and then he wrote the sentence, "Physicists are not supposed to write." The universe must have known from the very beginning that life was coming. Physicists do not write sentences like that. The universe is not supposed to know things, but the math kept saying it. So Dyson said it, which leaves a deeper question wide open. Who or what was doing the setting? The answer began arriving 9 years before Dyson, from a completely different direction, and not from cosmology at all. In 1907, Ilya Prigogine, a chemist at the Université Libre de Bruxelles, walked onto a stage in Stockholm to accept the Nobel Prize in Chemistry. He was being honored for something obscure: thermodynamics of non-equilibrium systems. The press did not know what to make of it, but what Prigogine had discovered would, decades later, answer the question Dyson asked. Prigogine had spent his career studying matter under conditions where energy is flowing through it, like water in a stream, like chemicals in a living cell. And he found something that overturned years of physics. Classical thermodynamics had said that matter, left to itself, falls into disorder. Entropy increases. Things break down. But Prigogine showed that when energy flows through a system at the right rate, the opposite happens. Patterns spontaneously emerge. Order builds itself. A whirlpool forms in flowing water, without a designer, without instructions, without any guiding hand. It just happens, because it is what energy does when it is moving through a medium. In his Nobel lecture, Prigogine said something that, in chemistry, was nearly heretical. The act of patterning matter is intrinsic to matter itself. When a planet reaches a certain complexity, life blossoms forth quite naturally, the way a whirlpool spontaneously forms in flowing water. Read that twice. Life is not an accident. Life is what matter does when it has been arranged for long enough. The universe does not need to know that life is coming. It only needs to be running. The whirlpool was always going to form, and we are the whirlpool. So the cosmologist said the dial was set. The chemist said the dial does not need to be set. Running the experiment is enough. Both answers point to the same uncomfortable conclusion. Life is not what the universe accidentally produced. Life is what the universe is for. But if life is what 14 billion years was building toward, you would expect to find evidence written into the planet itself, not in physics, not in chemistry, in the rock. In 2010, the mathematical cosmologist Brian Swimme, based at the California Institute of Integral Studies in San Francisco, flew to the Greek island of Samos to film a documentary called The Universe Story. He did not go for the beaches. He went because Samos is where the question began. Swimme's project was simple in scope and impossible in execution. He wanted to trace the entire 14 billion year cosmic story in physics data alone, from the Big Bang to the moment a human being asks, "Why am I here?" He wanted to see if it was one continuous story. What he found, frame by frame, was a 25% problem. Over the last 4 billion years, the sun has slowly increased in luminosity by more than 25%. By every law of thermodynamics, Earth should have boiled. The oceans should have evaporated. Life should have been extinguished long before vertebrates ever arose. But Earth maintained life-compatible temperatures the entire time, through ice ages and warm ages, through asteroid impacts and continental drift. The planet stayed in the narrow band where liquid water could exist. How? Swimme traced it. Marine algae and plankton, beginning roughly 2 billion years ago, were pulling carbon dioxide out of the atmosphere and locking it inside calcium carbonate shells. When they died, those shells sank. Carbon was buried. The greenhouse effect weakened, just enough, and only just enough, to counteract the rising heat of the sun. The planet was not a passive backdrop. The planet was actively cooling itself, using the bodies of the smallest creatures alive on it. Life was running the climate for 2 billion years. This wasn't biology adapting to a planet. This was a planet adapting itself through biology. Earth is not a stage on which life appeared.